Hey you two friends, let me show you what I got here. First thing I did is I lowered the lights down. They're not as high as they used to be because I have to get more light on the work. And let me show you what I had done here. I cut all the leads coming off of this uh, electrolytic capacitor can. And there's 3 capacitors inside of there. An 8, an 8, and a 6. Now the 6 was used, the 6 microfarad that is. The 6 was used over here where my finger is, right here, and that is goes to where this choke is. I think it's part of like an RF choke. So I had a hard time getting 6 microfarads, so I just substituted an 8, and that's about 22%, a little too high, but I think that will be okay. Now the other ones are 8s, and I use 8, like the ones that come off the rectifier. You kind of want to use the values that specify with the radio. You know, if you go too high on those, it'll draw too much current through the rectifier. But let me show you what I did here. You know, because I cut the wires like flush here with a can, what I did was, I don't know if you can see that, but I got my 3 new spray electrolytics, and I put a tie wrap around one of them, and then there's another tie wrap that goes around here so it holds it to the can like really secure. And I put electrical tape to tape these 3 together. Then I wired it into the circuit here. And on this one, see, this goes to ground, so that ground wire goes to this bakelite block. I'll put the light on that. And I rebuilt this bakelite block, and this resistor is intolerant, so I left it. This one was right at tolerance, and by tolerance, I'm like using like 10%, 10, 11, 12%. That's about as high as I'm going. So it was right at like 10, 11%, so I changed it. And I had one. I had a 25K, so I might as well just put it in because I'm working on it. So that's good. And now here, I replaced 2 of the paper capacitors with these orange drops. So I got those in, and you see where I heat shrinked here? I heat shrink all the leads, and that goes into the tap of this tone control thing. So I took I used a solder wick and got the old leads out. Then I soldered them on, and just like I did up here, see, I got like the heat shrink all on here, so it's all heat shrinked really good, so nothing's going to short out. Now what I got to do now, oh yeah, also I ohmed out these resistors, and they're in spec, so I'm like, okay, that's fine. Those resistors are good. And the funny thing is that you'll get a kick out of this. When I put my volt-ohm-meter on the high ohm scales, uh, it checked out okay for this old paper capacitor. So, but you know, what's the sense of leaving it in? I'll be honest with you. I mean, let's see, the working volts of this is, let's see, it's 400 working volts. But, you know, how long is it going to last before it shorts or something? Or maybe the value isn't correct. It's supposed to be 0.008. But I was surprised that it wasn't shorted out. You know, it really surprised me. So, anyway, what I wanted to tell you was a couple of things here. Oh yeah, here, watch. These, I got to replace these electrolytic cans here. Now, do you see how the wires go to like the tabs here. Now that would be a real convenient place to like solder to, but you can't. And I'll show you why. It's sorry I'm a little jittery there. I gotta show you something. See, if you I disconnected all the leads here on this one, and if you go like from here to the chassis, watch this. See, it's breaking down on the insulation. That's about 4 mega ohms, 5 mega ohms, and that's because there's just a piece of cardboard, and on the other side there's a clamp that goes around there, and between the cardboard and the clamp I'm getting like 4 mega ohms, and you really don't want to have just a piece of cardboard separating you and 300 volts. I don't think that's a good idea. And besides, the can will be energized, but just because the cardboard goes around there, if you look around the other side, see here, this metal can will be energized at 300 volts. So you don't want that. So the whole thing is that you have to, what I'm going to do is get the wires off. I'm going to have to rewire it in such a way where I'm not using that. And like these are shorted out. I went between here and here, and these electrolytics, that one's shorted. So that's definitely a bad part, and you want to replace those anyway. But when I was unsoldering that wire, well, this is an extension. The wire that was on there was this one here, and when I pulled it back, it cracked because the wire is a little brittle. So I put some electrical tape around there, and where it goes into the transformer, I gooped them real good with high voltage dope, because the cloth covering started to crack on that when I pulled the wire back. So I gooped it real good, and what I did was I added the extra piece of wire. Now this is orange wire, like an orangey color, and this is like an orangey color with a green tracer stripe, but you can't get, like, I can't find out where you find those wires with tracer stripes in anymore. So I just used the orange wire. That's spliced on, and I have heat shrink around it, and that goes behind this filter choke. So that's the wire that I can use to solder my components to. And I think what my plan is, I'm going to use like these terminal strips that I'm just going to solder to these, and the strips will have like the tie points on that I could solder things to. But I just wanted to mention that you really don't want to solder actively to these. Use these as active solder points, if you know what I'm saying. If you want to solder a terminal strip to there on the inactive part of the terminal strip, that's fine. But since these are shorted out, and you don't want like 300 volts separated from the chassis with a piece of cardboard. So I hope I made that plain. But what I want to show you this too. This is interesting. Now, the way they built this radio is have a floating B+. So I hope this shows up. I'll get a little pointer here. But if you look here, this, I don't know if you can see how they drew this, but there is a this is the electrolytics here, and in the middle they have like a little, more like a little dot, and it goes up to that, and this is the part where it goes to the negative point of the B+, and up here is the positive point of the B+. And if you look here, here's another. This is a 10 microfarad capacitor, and this goes to ground. And what I wanted to mention though is that since this is the floating B plus, and this is the negative, like the B minus, like the negative part of the B plus, this is more negative than the ground is. So even though this is ground, the electrolytic has to go in where the ground goes to the positive part of the electrolytic capacitor. And let me show you that. See, here's the capacitor here. This is the 10 microfarad that I'm going to use. So the arrows point to the negative, and this little ridge here that goes around is the positive. So you would probably normally think that the negative would go to the ground and the positive would go somewhere else, but not so in this particular case. In this case, it's reversed, and the negative goes to like the negative part of the B plus, which is this line here, and the positive end of the capacitor electrolytic actually goes to ground. So I know that's counterintuitive, but that's how it's supposed to go. In this case, this is the only capacitor in the radio that does that, but it's kind of floating the B plus. So they use this capacitor to float the B plus, so the positive goes to the ground in this particular case of this particular one capacitor. So just wanted to point that out. That's something to look for. And of course, this is the positive part of the B plus, and these capacitors go on normally where this is positive and this is the negative, and that's the positive and that's the negative. So that's what I wanted to mention. So have a good weekend, folks. And I'm going to put it away now. I put a number of hours into it, and there's no sense of like working on this like when you get tired and stuff, or when you get like frustrated. But I'm making pretty good progress. At least I got this capacitor taken care of with these 3 capacitors, and I triple checked that, and those are wired incorrectly. And now it's to just the point where I have to take care of this one, and this is a dual capacitor here, this one. So I'll get all this power supply section wired up, and I'll show you in the next video, maybe a couple days. Take it easy. Bye.